To the mind behind the weapon, the Hotchkiss M1914 and the industrial minds who powered static warfare. The smell of gun oil and metal shavings hung thick in the Saint-Denis workshop on that November afternoon in 1913. Lawrence Benet stood before the disassembled Hotchkiss M1914, his hands dark with grease, studying the feed mechanism that had just jammed for the third time that day. Beyond the workshop windows, Paris hummed with the confidence of a nation that believed the next war would be swift, decisive, glorious. Inside these walls, an American-born engineer was perfecting a machine that would make glory impossible. The barrel lay on the workbench, its distinctive cooling fins catching the late afternoon light. Benet ran his fingers along the machined steel, feeling the precision tolerances he and Henri Mercier had spent months calculating. Air-cooled. No water jacket. No frozen tubes in winter, no boiling water under sustained fire. On paper it was elegant. In practice, the prototype had just failed its most basic function. 3 jams in as many hours, Henri Mercier said quietly from across the room, not looking up from his drafting table. The feed strips are binding when the brass heats up, Benet replied, wiping his hands on a cloth already beyond salvation. We're a fraction of a millimeter off somewhere, or we're chasing an impossible solution. Benet didn't answer immediately. He picked up the barrel, feeling its weight, the careful distribution of mass, through those cooling fins they'd argued over for weeks. The French military observers who'd visited last month had called it over-engineered nonsense. Colonel Duchamp had been particularly dismissive, suggesting they simply order more Maxim guns and stop wasting the Republic's time. But the Maxim, for all its proven reliability, weighed nearly twice what this weapon did. Its water jacket made it a beast to move under fire. And in the kind of warfare Benet suspected was coming, though no one wanted to hear it, mobility and sustained fire would matter more than anyone could imagine. We test again tomorrow, Benet said finally. Different chamber tolerances. Mercier looked up, his eyes tired. He was 10 years older than Benet, had seen more French military bureaucracy, had learned when to fight and when to accept defeat. But something in the American's certainty made him nod. The two men had formed an unlikely partnership when Benet arrived at Hotchkiss & 15 years earlier, fresh from the Colt Armory in Hartford. Benjamin Hotchkiss, another American expatriate, had built an arms empire in France. Now he was dead, and his company was trying to compete in an increasingly dangerous arms race. Benet had pitched his air-cooling concept within his first year. Most engineers dismissed it. Water cooling was proven technology. Why reinvent the mechanism? But Benet had studied combat reports from colonial wars, from South Africa to Manchuria. He'd read about machine gun crews who'd run out of water under sustained fire, about frozen cooling jackets at high altitude. The air-cooled design was an answer to problems most procurement officers didn't believe existed. It was lighter, simpler in theory, requiring no external cooling infrastructure. But it demanded precision engineering that pushed the limits of French manufacturing capability. Do you remember what Duchamp said? Mercier asked suddenly. French soldiers need robust simplicity, not delicate American clockwork. I remember. He also said the next war would be over by Christmas. If he's wrong about that, maybe he's wrong about this too. Outside, the light was fading. Workers were leaving the factory floor. Benet and Mercier remained, as they had so many nights, bent over a weapon that might change warfare or might simply bankrupt their careers. The Hotchkiss M1914 lay between them, 4 years of obsession rendered in steel, waiting to prove whether an American engineer's intuition was genius or delusion. Benet locked the workshop door behind them, but he couldn't stop thinking about the chamber dimensions. Somewhere in those measurements was the answer. It had to be there. Because if it wasn't, if Duchamp and the skeptics were right, then soldiers would go to war with weapons that failed them when they needed them most. He didn't yet know that within 9 months, the Western Front would stretch from the Channel to Switzerland. He didn't know that his weapon would help create a 4-year siege that would consume millions of lives. He only knew that tomorrow he would test again. If stories like this make you question what you do when everyone says you're wrong, but you know you're right, tell us in the comments and stay with us for the next chapters. Lawrence Benet had not intended to become a weapons designer. As a boy in New York in the 1870s, he'd simply loved mechanisms, the honest logic of gears and springs, the way properly machined parts moved together with inevitable precision. While other children played with toy soldiers, young Lawrence disassembled his mother's sewing machine and reassembled it with improvements she hadn't requested. His father, a minor clerk in the Army Ordnance Department, recognized the gift and secured his son an apprenticeship at the Colt Armory in Hartford, Connecticut. The Colt factory taught him that weapons were fundamentally machines, problems of metallurgy, thermodynamics, and mechanical reliability. They weren't instruments of glory. They were tools that either worked or got people killed. By his mid-20s, Benet had earned a reputation as the man who fixed problems others considered inherent to design. When Benjamin Hotchkiss's company in France sent recruiters looking for American precision engineering talent, Benet was on their list. Paris, in 1898, seemed impossibly distant from Hartford's factory floors, but the challenge was too compelling to refuse. André Mercier had been the first person to speak to him at Hotchkiss, with something other than barely concealed resentment. The French engineer was already in his late 30s, a veteran of multiple failed weapons programs, and he carried the weary patience of someone who'd learned that most engineering problems were actually political problems in disguise. "You're the American precision man," Mercier said on Benet's first day. "They say you can machine tolerances to the thousandth of an inch. If the metal and the tools are good enough, yes. And if they're not, then we improve the metal and the tools." Something in that response made Mercier smile. Over the following months, they fell into an unexpected partnership, Mercier navigating French military politics, Benet pushing the boundaries of what their workshops could manufacture. The air cooling concept emerged during their first year working together. Benet had been studying reports from the Russo-Japanese War, where machine guns had proven devastatingly effective but operationally fragile. Water-cooled weapons required constant resupply. In winter, the water froze. Under sustained fire, it boiled. "What if there was no water at all?" Benet asked one evening, sketching rough cooling fin designs. "Then the barrel melts," Mercier replied automatically, then paused. "Unless you could dissipate the heat another way. Convection, surface area, airflow over machined fins. The metallurgy would be brutal, the tolerances impossible." "Difficult," Benet corrected. "Not impossible." That distinction between impossible and merely difficult would define the next 14 years of their lives. The initial designs were promising enough to secure limited funding. The French military showed polite disinterest. Their procurement doctrine centered on proven designs, and the Maxim gun had been proven in colonial conflicts from Sudan to Indochina. By 1906, they had a working prototype. By 1909, they'd refined the cooling fin design. By 1911, they'd convinced Hotchkiss to invest in serious testing, and then came the failures. The weapon jammed in dusty conditions. The feed strips bent under stress. The chamber dimensions proved problematic. Colonel Duchamps made his opinion brutally clear during a 1912 review. "Gentlemen, France faces the most mechanized military in Europe across the Rhine. We need weapons we can produce by the thousands. This," Duchamp gestured at the disassembled prototype, "is a masterpiece of American precision that will never survive French infantry." "Give us 6 more months," Benet said. "I've given you 5 years. After Duchamp left, Mercier slumped at his workbench. He was 50 now, too old to start over if this project collapsed. Benet, barely 40, still carried the immigrant's certainty that persistence would overcome institutional inertia. "Maybe he has a point," Mercier said quietly. "Maybe we've been chasing elegance when war demands brutality." Benet didn't answer. He was staring at the chamber dimensions again, running calculations, convinced the solution was hiding in fractions of millimeters. In Hartford, his mother wrote letters asking when he'd return to America. In Saint-Denis, his workshop grew colder as autumn turned to winter. And across Europe, generals planned for a war they promised would be over in months, using tactics from the previous century against weapons from the next. The breakthrough came in pieces, not revelation. Through the winter of 1912 and into 1913, Benet and Mercier worked with the methodical patience of men who'd stopped believing in sudden genius. They adjusted chamber dimensions by fractions, tested barrel alloys, refined the cooling fin geometry. Each small improvement brought them closer to reliability, but never quite achieved it. The French military bureaucracy continued its elaborate dance of procurement committees and doctrinal reviews. The Hotchkiss M1914 had become a minor curiosity, the American engineer's obsession, tolerated but increasingly seen as a dead end. The Germans have the MG-08, a junior procurement officer named Laurent explained during a February visit, water-cooled, proven, being produced in the thousands. Why would we invest in an unproven system? Because when this war everyone keeps predicting actually starts, you'll need weapons that don't require supply wagons full of water, Benet replied. Laurent made a note, his expression suggesting he was filing the comment under American optimism. That possibility haunted Benet's sleepless nights. In his small apartment near the factory, he kept files of combat reports from every conflict of the past 2 decades. The patterns were clear to anyone willing to see them. Modern rifles had made frontal assaults suicidal, artillery had become devastating, and machine guns, despite their operational challenges, had proven capable of stopping attacks that would have succeeded a decade earlier. The next war, if it came, would be decided by firepower and industrial capacity. The side that could maintain sustained fire longest would control the battlefield. It was mathematics, not glory. His personal life had narrowed to the dimensions of the workshop. He'd never married, had no family in France, beyond the engineering community at Hotchkiss. Mercier sometimes invited him to dinner, where Benet would sit quietly, making awkward conversation. "Henri says you work too much," Madame Mercier told him once. "A man needs more than his work." Benet had no answer that wouldn't sound pathological. How could he explain that the weapon was a moral obligation to soldiers he'd never meet, who would fight a war he hoped would never come, but knew probably would? The air cooling system finally stabilized in April 1913, but the feeding mechanism remained temperamental. Under sustained fire, the metallic strips still jammed when the hot chamber caused fractional brass expansion. "It's the chamber walls," Benet realized one evening. "We've been treating the chamber as fixed geometry, but it expands microscopically when hot." "Everything expands when hot," Mercier replied. "That's thermodynamics. But if we machine the chamber with slightly tighter tolerances when cold, accounting for thermal expansion, the hot geometry becomes optimal instead of problematic." It sounded simple. In practice, it meant machining chambers to tolerances that would require new tooling. It meant convincing management to invest in retooling for a weapon the military still considered a curiosity. "How much tighter?" Mercier asked. 0.003 inches, maybe 0.005. "That's insane. Production won't be able to maintain that consistency." "Then we improve production." Mercier studied his partner's face, the certainty bordering on delusion, the absolute conviction that will and precision could overcome institutional skepticism. He thought about his own career, the comfortable safety of working on proven designs. Then he thought about his sons, 16 and 14, growing up in a Europe where every crisis brought the continent closer to war. If fighting came, those boys might be conscripts, and conscripts deserved weapons that worked. "I'll talk to the production manager," Mercier said finally. "But this is the last redesign. If it fails, we're done." "It won't fail." "You can't know that." "No," Benet admitted. but I can make it as close to certain as human beings are capable of making anything. Outside, Paris was preparing for summer. Inside the workshop, two engineers committed to one final iteration of a weapon that might never see combat, might never prove its skeptics wrong, but they would machine those chambers to impossible tolerances anyway, because mathematics didn't care about institutional inertia. Do you think you'd fight the system for what you believe works, or accept what doctrine says is impossible? Comment which path you'd take, and share this episode with someone who loves real innovation stories from history. The retooled production line began delivering the new chamber geometry in June 1913. Each chamber was measured 3 times before approval, machined to tolerances that made the production manager quietly furious. Half the initial batch failed inspection. Benet insisted on maintaining the standard. The workshop atmosphere grew tense with the knowledge that this was their final attempt. The test was scheduled for early August at a military proving ground outside Paris. Colonel Duchamp would attend, along with procurement representatives and Hotchkiss executives. Success meant potential military interest. Failure meant the end of 14 years of work. The night before, Benet couldn't sleep. He lay in his apartment, mentally reviewing every specification, every calculation, every potential failure mode. The weapon was as perfect as he knew how to make it. But perfect in a workshop didn't guarantee reliability under field conditions. At dawn, he and Mercier loaded the prototype and ammunition into a truck. They barely spoke during the drive. The weapon would work or it wouldn't. Mathematics would prevail or it wouldn't. The proving ground was a muddy field ringed by observation bunkers. Duchamp arrived precisely on time, his uniform immaculate. He nodded curtly at Benet and Mercier, then took his position. The message was clear: prove me wrong or stop wasting my time. Commence firing, the test officer ordered. The first burst was perfect. Smooth cycling, reliable ejection, no jams. Benet continued firing, watching the barrel temperature rise, waiting for the thermal expansion that had plagued every previous test. 20 rounds, 50, 100. The weapon maintained its rhythm, the cooling fins doing their job, the precisely machined chamber accommodating the hot brass without binding. 200 rounds, 300. Duchamp emerged from the observation bunker, his expression unreadable. Benet focused entirely on the weapon, on every microscopic indicator that might signal impending failure. 500 rounds. The barrel glowed with heat, but the cooling fins were dissipating it exactly as calculated. No water, no cooling jacket, just physics and precision engineering. "Stop!" Duchamp called out. Benet's heart sank. Had he seen a problem? "How many rounds can it fire continuously?" Duchamp asked, his voice carefully neutral. "We've tested up to 2,000 in controlled conditions," Mercier answered. "We have ammunition," Duchamp said. "Continue until it fails, or until we run out." The next 2 days became legendary. Benet and Mercier rotated shifts, feeding ammunition strips as the M1914 fired thousands upon thousands of rounds. They paused, only to let the barrel cool enough to handle, then resumed. The weapon absorbed punishment that would have destroyed water-cooled guns. At 30,000 rounds, with Duchamp still watching and ammunition nearly exhausted, the test officer finally called a halt. The weapon had not jammed once. The cooling fins showed thermal stress, but no structural failure. The chamber geometry had performed flawlessly. Duchamp approached, studying it with an expression that might have been respect. "This is not the weapon I expected," he said finally. "The engineering is remarkable. But you understand that remarkable engineering means nothing if we cannot produce them in quantity. Our industry must be capable of maintaining these tolerances in wartime production conditions." "With respect, Colonel," Benet replied, his voice hoarse, "France has the finest precision manufacturing capacity in Europe. If this weapon can be made here, it cannot be made anywhere." "Perhaps," Duchamp said. He turned to his aide. "Prepare a full evaluation report for procurement." include production feasibility analysis and cost projections. After he left, Benet and Mercier sat in the observation bunker, too exhausted for celebration, too pragmatic for optimism. They'd proven the weapon worked, but Duchamp's concerns about wartime production were legitimate. "We'll need to train production workers, develop inspection protocols," Mercier said, already thinking through the industrial challenges. "If there's time," Benet added quietly. "You still think war is coming?" "I think war is always coming. The only question is whether we're ready when it arrives." They packed the weapon carefully. In that moment, holding the result of 14 years of obsession, they felt something close to peace. The weapon worked. The mathematics had prevailed. Whether the military adopted it, whether history would remember their names, those questions belonged to the future. War came 11 months later, not with swift, decisive campaigns, but with mobilizations so massive they jammed railway systems across Europe. By September 1914, the Western Front had calcified into trenches that would barely move for 4 years. The war of movement was dead. The war of firepower had begun. The Hotchkiss M1914 went to war with approximately 2,500 units distributed among French forces, not nearly enough, but more than the Germans expected. Procurement had accelerated production after the August 1913 tests, though maintaining precision tolerances at scale proved as challenging as Duchamp had warned. Benet spent those months traveling between factories, training workers, carrying the weight of knowing that every quality failure might cost lives. The first combat reports arrived in October, dispatches from the First Battle of the Marne. One letter, from Sergeant Auguste Ferrand, described the weapon's performance with blunt honesty. "The Boche came at us in waves, like they did not believe machine guns could stop brave men. Our Hotchkiss sang all morning, no jams, no water to worry about, just load the strips and keep firing. By noon, they stopped coming. By evening, they were digging trenches just like us." That last sentence haunted Benet more than the praise. They were digging trenches. Both sides facing each other across fields turned into killing grounds by reliable, sustained machine gun fire. By early 1915, the pattern was undeniable. The Western Front had become a continuous, fortified line from Channel to Switzerland. Machine guns, properly positioned, could sweep entire attack zones. Infantry assaults that would have succeeded in 1870 now resulted in catastrophic casualties. The Hotchkiss M1914, along with German Maxims and British Vickers guns, had fundamentally changed the mathematics of warfare. French High Command struggled to adapt. General Joffre insisted on maintaining offensive doctrine. The spirit of élan, the belief that properly motivated infantry could overcome any obstacle. But the numbers told a different story. A single machine gun could suppress attacking infantry across 400 meters of front, firing 450 rounds per minute. No amount of courage changed that geometry. "They're calling them the meat grinders," Mercier said one evening in the workshop. "The soldiers, I mean. Not the weapons. Us." Benet was adjusting yet another production sample. He understood what Mercier wasn't quite saying, that the weapon they'd designed to save lives through effective defense was helping trap millions of men in trenches where death came from disease, artillery, and attrition. "We made the weapon we were asked to make," Benet said finally. "We solved the technical problems we were presented with, and created new ones no one asked us to solve." By mid-1915, demand for machine guns exceeded every pre-war projection. Hotchkiss factories employed thousands of workers, many of them women. Production had scaled from workshop craft to industrial mass production. The precision tolerances that had seemed impossible in 1913 were now maintained by workers who'd been housewives months earlier. The M1914 appeared in every sector of the Western Front. American Expeditionary Force units adopted it as one of their standard heavy machine guns. By the armistice in 1918, over 47,000 units had been produced. The weapon had become ubiquitous, so common that soldiers barely remarked on its presence. Benet received official recognition in 1916, a Legion of Honor medal presented by a grateful republic. He accepted it in a brief ceremony at the factory, surrounded by industrial machinery, now mass-producing the weapon he'd once built by hand. The medal felt heavy in ways that had nothing to do with its physical weight. "You should be proud," the minister said. "Your innovation has saved countless French lives." Benet nodded politely, not mentioning that it had also helped ensure those lives would be spent in trenches for years, or that the stalemate created by effective machine guns on both sides had its own terrible arithmetic. Pride seemed like the wrong emotion for understanding you'd designed something so effective at its purpose that it had changed the nature of war itself. The armistice came on a November morning in 1918, 4 years almost to the day after that workshop afternoon, when Benet had first contemplated the cooling fins that would define his legacy. The trenches were evacuated, the machine guns fell silent, and Europe began counting its dead, numbers so large they lost meaning. Benet was 65 now, his hair gone white, his hands still steady, but marked by decades of work. He continued at Hotchkiss through the post-war years, though the work had changed. The company shifted to sporting rifles, automobile parts, civilian manufacturing. The urgent production that had consumed the war years slowed to peacetime rhythms. But Benet found he couldn't quite return to that peacetime mindset. He'd stand at workshop windows, staring northeast toward where the front had been, thinking about Sergeant Ferrand's letter and thousands like it. Soldiers who'd survived because the weapon worked. Soldiers who died because weapons on both sides worked too well. Mercier, now in his 70s, noticed the change. They still worked together, but the easy companionship of pre-war years had been replaced by something heavier, a shared understanding of what they'd helped create. "Do you regret it?" Mercier asked one evening. "Every day," Benet admitted, "and never. The weapon did what we designed it to do. It saved French soldiers' lives. But the war it saved them for—" He didn't finish. They'd both seen the casualty figures, understood that their reliable defensive weapon had contributed to a strategic stalemate that consumed a generation. "We were engineers," Mercier said quietly. "We solved the technical problems we were presented with. We can't be responsible for how military doctrine failed to adapt." "Can't we?" The question hung between them, unanswered. They were not strategists. They'd designed a tool. But tools shape users as much as users shape tools, and the M1914 had helped shape a war where defense became overwhelmingly superior to offense. In 1920, the French military conducted a comprehensive review of wartime equipment. The Hotchkiss M1914 was officially recognized as one of the war's most successful weapon systems. Reliable, maintainable, effective. Recommendations were made to maintain production capacity for future conflicts. Reading those reports, Benet felt a peculiar mixture of vindication and dread. They'd been right. The weapon had proven itself beyond question. But being right about creating an effective tool for static warfare felt like the emptiest kind of victory. He began declining interviews. When young engineers asked about the M1914's development, he'd answer technical questions but avoid discussing the war. Mercier covered for him, understanding that some knowledge was too heavy to speak about casually. A historian visited in 1925, researching French weapons development. She was enthusiastic, convinced that technical innovation had won the war. "What was your greatest innovation?" she asked. Benet thought about the pocket watch he'd restored as a boy, which had kept time for decades without ever harming anyone. "Tighter chamber tolerances," he said finally. 0.003 of an inch made all the difference. And you must be proud of how your weapon performed in combat. I'm proud that we solved the technical problems. Whether the solution was worth its cost, that's for others to determine. In the end, the weapon endured in ways its creators never would. It sat in museums and arsenals, was studied by historians, appeared in photographs of the Western Front. The cooling fins that Benet and Mercier had argued over became iconic, instantly recognizable. But the minds behind the weapon, the American engineer who'd come to France with precision tools and impossible dreams, the French partner who'd helped turn those dreams into reality, they faded into the quiet obscurity of technical specialists who'd done their work too well. Their names appeared in procurement documents and engineering journals, but rarely in histories that focused on generals and battles. Perhaps that was appropriate. They'd been engineers, not warriors. They'd solve problems of heat dissipation and feed reliability, not questions of when defensive firepower becomes too powerful. Those questions belonged to strategists and philosophers. The last thing Benet designed at Hotchkiss was a mechanical clock, precision engineered to keep time for decades. It never hurt anyone. It never saved anyone. It simply existed, doing what it was made to do, without moral weight or historical consequence. Sometimes he thought that might have been the better legacy. If this story reminded you that changing the world often means being right before anyone believes you, subscribe to the channel, tell us which country you watch from, and invite someone to revisit history with us in the next story.